Yeah, good morning, ma'am. Yes, am I audible?
Yes, sir.
Yes, sir.
Yes, most of you have missed the previous class, which is conducted online. I wanted to revise those things once briefly. We have started with what is meant by virtualization. It's a providing virtual component that can be a hardware component or software component in order to utilize by multiple users. That is what basic concept of virtualization. It is like virtualization is a computer architecture technology by which multiple virtual machines will be trying to, like physical machines will be having. On top of physical machines, we will be building virtual machines which will run on the same hardware, same physical machine. Okay, this is what basic concept of virtualization. And what is the use of constructing these virtual machines is whatever the physical resources we are having, those resources can be utilized properly, or with we can say more utilization we can achieve due to this virtual machines. That is, suppose if you have your own PC at your home, which can be utilized by you, but you will be using for certain amount of time. But on top of it, if you create an interface where it will look like four systems, four virtual machines, four people can utilize, then those resources can be all the time utilized. Such kind of virtual machines we will be building. That process we will be we will call it as virtualization. Okay, what is meant by virtual machine actually is, it is like virtual machine is nothing but I'll be showing this. Yeah, this is a virtual machine, like representation of a real machine. Using some software, we will be providing some operating environment. Okay, such that whatever the guest operating system which is required by end user, that can be installed on it and can be utilized as a real machine. That is what virtual machine. It is like on top of physical machine, we will be creating some environment, some operating environment or execution environment, eh, which can run guest operating system, which can hold guest operating system, so that guest can able to run his or her own program on the required operating system, although the physical machine is having some other operating system. Such kind of operating environment we will be creating. That machine we call it as virtual machine. Okay, next, what is meant by guest operating system? It is like guest operating system is nothing but the guest is requiring some sort of operating system. Okay, that we call it a guest. There is no distinction that these kind of systems are operating systems are guest, these are not like that. It's like Windows we can use as guest operating system, or Linux we can use as the guest operating system, or some other things, Solaris or Mac, all these things we can use as guest operating system. It is like whatever the environment which is required by the guest is nothing but guest operating system. Yeah, now after now we have seen what is meant by virtualization, what is meant by virtual machine and guest operating system. Next, now coming to the differentiation between general computer or the traditional computer, and after performing this virtualization, how the architecture will look like is, see here in the left side of the diagram, you are having a traditional computer. It's like we will be having hardware devices like hard disks, what you call networks, storage, all these things will be having processors. These all we will be having. On top of it, one operating system is installed. That operating system we call it as host operating system. Okay, host operating system. On top of it will be running some application. Okay, this is traditional computing. It's like in our computer also we will be having some computer or laptop will be having some hardware, some processing device, some storage, some networking capability. All these things will be having physically. On top of it, some operating system we have installed like Windows 10 or Ubuntu or Linux or some operating system we have installed. That operating system we call it as host operating system. On top of it, we are running one application. It's like browser is one application. Google Chrome we are running, or Microsoft Edge we are running, Firefox. These all are applications. Those applications we are running on top of host operating system, which is running, which is used to operate on top of physical hardware. Whereas if you apply virtualization on this particular traditional computer, then how it will look like is, it's like whatever the hardware devices, whatever the physical hardware devices we are having, on top of it we will be building some virtual machines. See here, this entire thing is a virtual machine. Virtual machine is having some virtual devices, virtual hardware devices, and guest operating system, and some applications. Like here, whatever the physical machine we are considering, these three components will be having in virtual machine as well. But here, whatever the virtual hardware devices we are saying, those are not exist, right? Because those are virtual. Although those are not exist, users should able to run their applications. Users should able to run their applications on top of physical virtual hardware. How it is possible is by making use of these physical hardware devices only. Okay, how these applications can communicate or can operate these is by using intermediate layer called virtualization layer. At this particular layer, we will be having a software or hardware component called hypervisor or virtual machine monitor, VMM, virtual machine monitor. We will be having hypervisor or VMM at a virtualization layer in order to assist virtual machines to use hardware, physical hardware resources. Got my point? What is the use of virtualization? It will assist virtual machines to access physical hardware resources. Okay. So now, in other words, what we can say is this virtualization layer will provide that virtual environments to these all virtual machines. Okay, that is in other. Yeah. So here, how many virtual machines we are having in this diagram is, this is one, this is one. Okay, this is one virtual machine where we are having virtual devices, guest operating system, application. Similarly, here also virtual devices, guest operating system, application. This entire thing we can say it as virtual machine. This is virtual machine. Next, in order to maintain these virtual machines, we are having virtualization here, and this is physical hardware. This is the difference. Now you can see the point. Traditional computer runs with a host operating system. Next, after virtualization, we will be having users. Every user can have their own operating system, which we call it as guest operating system, which can run on same hardware, but it is independent of the host operating system. Okay, this is done by using the layer called virtualization layer, and the software or the hardware component we call it as hypervisor or virtual machine monitor, in order to achieve this or in order to attain the functionality of virtualization layer. Okay, next, this we have seen what is meant by virtual machine, what is meant by guest operating system. Yeah. Next, this user's perspective, they will be thinking that they could able to use mail service, some web storage, as web storage we can use all these things. These all are user applications, but in order to achieve these functionalities, we need to use physical resources. In order to achieve this one, we need storage, web store, we need some interconnectivity. All these things we require. How it can be done is it can be provided is by using a layer, virtualization layer. Okay, this is a user's view. Next, this virtualization we can provide at 5 different abstraction levels. That is, we can provide virtualization at ISA level, hardware abstraction layer level, that is on top of hardware, on top of operating system, on top of a library. Up as application, we can provide this virtualization facility. Got it? There are 5 different abstraction levels while providing virtualization. That is, we can provide virtualization at application level, we can provide at operating system level, we can provide even at instruction set architecture level. Okay, instruction set architecture is lower than this hardware abstraction level. That next we'll be seeing one by one these 5 techniques, 5 abstraction levels. Virtualization at ISA, it is nothing but we will be creating one emulator which will translate the given ISA instruction set architecture to the required ISA. Okay, that is guest may give one instruction set architecture, instructions in one ISA that can be translated to the host machine ISA. Okay, by using an emulator. Example is MIPS is one binary code and it can run on x86. This is the host machine. Host machine ISA is x86. Guest is MIPS. So whatever the instructions given in MIPS, that can be translated to x86. These are the examples of some systems where we have used virtualization, we have applied virtualization at ISA level. Bird, Dynamo, these all are some example systems. What is the advantage of this one is large amount of binary code can be easily translated to other new hardware host machines. Although we are having traditional legacy code with us, we could able to translate it to new host machines where we are having a recent ISA instruction set architecture codes. We can able to translate and we can execute that program. Okay, what is the disadvantage of having such kind of emulator is one particular instruction may translate it to hundreds of lines or some 20-30 such kind of such number of lines. One instruction in the traditional code may need to translate it to 10 or 20 lines of code in the new one. Okay, that is one thing. And one more thing, some instructions may not be available. Equivalent instructions for one particular instruction may not be available in the new architecture. Then what can be done is we need to stop those kind of instructions while compilation itself. So that compiler support we should incorporate in order to judge whether that instruction can be translated or not. These are the disadvantages of virtualization at ISA, but one very good advantage is application flexibility is more. Okay, so this is about the instruction set architecture level virtualization. Okay, next hardware abstraction level, that is the second one. Here we have seen this instruction set architecture level, the bottom one. Next we will be seeing hardware abstraction layer level. That is here we are performing virtualization on top of the hardware. That is, we'll be creating some virtual hardware environments for virtual machines. We have seen what is meant by virtual machines. For those virtual machines, we'll be creating some virtual hardware environments which will be managing the actual hardware through its virtualization. Okay, such layer we will be building on top of the hardware, so that we could able to provide virtual hardware environments. Okay, these are the examples: VMware, virtual PC, Zen is very very important. These we will be using at a hardware abstraction level while implementing virtualization. Okay, these are the typical examples, and the advantage is high performance and application isolation will be more in this hardware abstraction level. Application isolation, we have seen what is meant by application isolation. Like we'll suppose while getting the computational power, some sort of storage, some sort of connectivity, all these things we could able to establish virtually, so that users or guests will feel that that entire environment is independent of any other system. Such kind of illusion we could able to provide. That concept we call it as application isolation. That property is achieved in this abstraction level. What you call more. Next, it is a little expensive to implement. This is the disadvantage of virtualization at hardware abstraction level. Next, coming to the third one, that is virtualization at operating system level. That is, we will be having a traditional operating system. It's like a host operating system we'll be having. On top of it, we will be building a layer called virtualization layer. There we will provide some operating environment. Okay, this virtualization creates isolated containers. What is meant by container is, it is a combo of this compilers, interpreters, all these things will be having, like whatever the operating system functionalities will be having, those all components we will be having in a container. Okay, as a physical server we will be having that container. Such kind of containers will be created by this virtualization layer between which is between host operating system and the user application. Okay, the examples of this kind of virtualization is performed in jail, virtual environment, and FVM. These are typical examples where we have applied this operating system abstraction level while implementing virtualization. Advantage or the benefit of using operating system level virtualization is very very easy to set up or easy to shut down this kind of virtualization. This is a main advantage of virtualization. Next, advantage of virtualization at operating system that you remember. Next, what is the disadvantage is, whatever the guest operating system we are having, those all guest operating systems should have some compatibility. Same type of guest operating system we should have as host operating system. Like Windows, some version if we use as a host operating system, then in the guest operating system what can be used? Windows compatibility. Windows other versions we can use at guest operating system, but not Linux. That is the restriction in operating system level. Okay. Next, this is the diagram related to it. Like we'll be having standard OS, we can say, as a host operating system, and OS virtualization layer, where we will be providing virtualization at operating system level, and through this we are trying to create several virtual environments. So each environment will have its own operating system, as we have seen earlier. Each virtual environment will be having its own operating system, which we call it as guest operating system. So that guest, these all three virtual environments will be having some guest operating systems. Those all three should be of type which is similar to standard OS. That is the disadvantage or the restriction that we have in this type of virtualization, that you remember. Yes. Next, whatever the virtualization schemes so far we are having, those are mostly Linux based virtualizations, but in Windows it's there is not much done happened in this particular area. Okay, these are the several what you call softwares are the examples where we are having virtualization at the operating system level. vServer, FVM, these are some examples for virtualization at operating system level. Okay, next, of course, we have seen this advantages and disadvantages. Cost will be less for establishing or what you call shutting down that virtualization. Yeah. Next disadvantage is same OS container must have the same or similar guest operating system. One container should have same type of operating system as guest operating system. Okay, this is this is the disadvantage. Why? Because it will limit the virtualization application flexibility will be losing. Yeah, this is the operating system level. Next, fourth one is library support level. This is most important one. Library support. It's like instead of establishing entire environment like what operating system, whatever the functionalities it will provide, instead of providing all the functionalities, what we can prepare, what we can provide is whatever the functionality which is required, those only we will provide. Okay, through API calls. That is library support level. See here, it creates execution environments for running LN programs on a platform rather than creating virtual machine to run the entire operating system. Instead of creating virtual machine to run entire operating system, what we will provide is some required programs. Okay, to run some required programs, we will be creating some platform. Okay, such kind of virtualization we can achieve by performing virtualization at a library support. Okay, library level you can say. What is the advantage is low implementation effort. Why? Because we are not implementing all the functionalities of operating system, so low implementation cost, but application flexibility and isolation is very limited. And examples of these are Wine, WAV, LXRun, Visual Main Win. These are the examples of the virtualization which is performed at a library level. Okay, and these are the things. These are the examples. WABA is nothing but Windows Application Binary Interface. This is one of the examples for virtualization at the library level. LXRun, Wine, Visual Main Win, vCUDA, and we have example for vCUDA as well. Here we are having one application which is running on guest operating system, but it is trying to create a virtual environment on top of this physical machine. But instead of creating entire thing, what it will be doing, it will make use of some virtual library which can create an illusion that there is a GPU associated with this guest as well. That is virtual GPU we could able to create. This entire thing we can say it as virtual environment which we have created at a library level. Okay. Next, the final one is a user application level. Here we will be considering one application as the virtual machine. An application itself we will consider as the virtual machine. What it will do is whatever the application which is running on top of the operating system. See here, this layer sits as an application program on top of the operating system and exports an abstraction of a virtual machine that can run programs written and compiled to a particular abstract machine definition. That is one particular physical machine will be having. On top of it will be having operating system. Then on top of operating system will be having application program. That application will itself will act as the virtual machine where we will be giving the input and it could able to compile and perform required operation as a virtual machine. Okay, examples are JVM, NetCLI, PANET. These are the examples of virtualization which is provided, which is implemented at a user application level or application level. Okay, it provides the advantage of this is it provides application isolation. As we have seen, application isolation we have seen earlier, that we will be getting more in user application level. Next, disadvantage is performance is low, but application flexibility also is low. Okay, these are the disadvantages of user application level. Examples we have seen. Next, this is the comparison of these all 5 different virtualization levels with respect to 4 different parameters: high performance, application flexibility, implementation complexity, application isolation, which is which will give more performance with respect to this one. Hardware virtualization or OS level virtualization will give high performance over all these 5. Application flexibility is more in ISA, as we have seen while discussing ISA itself. Application flexibility is more in ISA. That is, even legacy soft code can also be translated into recent ISA, so that we could able to execute that on current ISA architecture. That is what application flexibility, that we could be able to achieve more when we create virtualization, when we achieve virtualization by using ISA translation. Yeah, next, implementation complexity is less in user application, hardware level virtualization. These two, implementation complexity is less. Next, coming to application isolation, which is which creates application isolation more, as we have seen in the previous slide. Here, the advantage of user application level virtualization is providing application isolation. The same thing is reflected here. Application level, if you perform virtualization, then it could able to offer more application isolation. Okay, this is what the comparison of these 5 different levels of virtualization with respect to 4 parameters. Okay, next, coming to the hypervisor. We have seen what is meant by hypervisor. It will sit between. Yes. Okay. Yeah. This hypervisor will sit between host operating system and the physical hardware and the virtual machines. Okay, this can be called as a virtual machine monitor as well, VMM. Okay, there are 2 types of hypervisors. We can say type 1, type 2. This we have seen in the previous class when we conducted online. We have seen type 1 and type 2. Type 1 we call, I think, native hypervisor. Native hypervisor is nothing but on top of physical hardware, this virtual machine monitor will sit. Okay, that software will be running on the actual hardware directly. Okay, that is type 1. Whereas type 2 is on top of the host operating system will be having this hypervisor, that is type 2. Okay, and there are some examples where we are having several hypervisors and their host processors, host operating systems, guest process, guest operating system. Guest CPU is nothing but the virtualizable CPUs. It's like one environment we are having physically. Okay, on top of it, what kind of virtual machines we could able to create. For virtual machine also we'll be having some CPU, right? Some sort of CPU we could able to create. Hardware, virtual hardware we should able to create. So what kind of virtual machines we could able to build, that is listed here. VMware Workstation, VMware ESX server, Xen, KVM. These all are the VMM provider. For those corresponding host GPUs, guest GPUs, host operating system, guest operating system are listed. Okay, and coming to the last column, that is VM architecture. That is how these virtual machines are being considered. There are several architectures: full virtualization, para-virtualization, like that we'll be seeing now. So by using those, these were implemented. These are the examples, just listing some example environments where we could able to provide virtualization. That's it. Yeah. And this, as we have seen earlier, Xen, right? In this list also it is there. Xen. It is the vertical. It is the system where we have used virtualization. Okay. This Xen is having. Xen is basically a hypervisor or VMM, where we'll be having several host guest operating systems. This is one guest operating system. This is another guest environment. We can say this is another one. Whatever the guest operating system which could able to control other guest operating system, we call it as domain 0. The guest operating systems which has the controllability, we call it as domain 0. Other than domain 0, remaining guest operating systems, we call it as domain U. Domain U is nothing but the operating systems, guest operating system, which are not having any controllability. Okay, the guest operating system which is having the controllability, we call it as domain 0. Okay, this is with respect to Xen architecture. See, the same points are available. The guest operating system which has controllability is called domain 0. It is not domain 0, and the others are called domain U. Domain 0 is a privileged guest operating system of Xen. First, it will be loaded, and then domain 0 is designed to access hardware directly. It could able to access the hardware device. Here we are having hardware device. Domain 0 could able to communicate with these hardware devices directly, whereas these can get access through this domain 0. Okay, these guest operating systems could able to get access to hardware devices through this domain 0. That is what the control ability we are having for domain 0. Next. Full virtualization, para virtualization. Full virtualization, basic point is, I'll show you here. This is in general virtualization, right? We'll be having hardware, then on top of it virtualization layer, then some guest operating systems applications will be having. Now, whenever we wanted to execute some programs, okay, some instructions on top of this hardware, if we allow all the operations directly to be performed here, then it may damage whatever the hardware resources we have. So that's why some instructions will be separated, which requires hardware resources to be modified. Those things we will segregate from normal instructions. Like we will be having instructions are of two types: privileged instructions, non-privileged or unprivileged instructions. Privileged instructions we should run with proper permission, with proper monitoring, under proper monitoring. Whereas non-privileged instructions we can execute directly. So those can be transferred directly to the hardware. Whereas this what you call privileged instructions we have, those we have to go through virtualization. Okay, such kind of flexibility we could able to achieve. Whereas full now coming to full virtualization. Full virtualization in the sense, whatever the instructions we will be providing, those instructions will go through virtualization layer only. Okay, all will be executed as privileged instructions, although those are unprivileged instructions. This is in the case of full virtualization. For that, we no need to modify any guest operating system. Whatever the operating environment we have, the same thing will be used, and virtualization layer will take care of all the instructions. Whereas para virtualization in the sense, here on top of this guest operating system, we will be building some other para virtualized guest operating system. Try to understand, guest operating on top of guest operating system, we will be modifying something, and we will say such kind of operating system as para virtualized guest operating system. What it will do is, whatever the operations which are privileged, those will go through virtualization layer, but non-privileged instructions will be converted as hypercars, which will go directly to the hardware. Such kind of thing we call it as para virtualization. Instead of going all the instructions through virtualization, we will send some user instructions which are unprivileged directly to the hardware. So such kind of flexibility we will be achieving in para virtualization. Okay, so here you can see this. This is with respect to full virtualization. Here we are whatever the user application we are having, it will be running on guest operating system. Then VMM will take care of these hardware resources. Whereas in the para virtualization, what will happen is, these user mode instructions which are unprivileged, those can be executed directly on the host operating system. That is the advantage, that flexibility we will be creating through this para virtualization. See here, para virtualized guest operating system we are achieving. Okay, so this is about yeah. So yeah, next virtualization of CPU, memory, and I/O devices. Here we are trying to create what CPU, memory, and I/O devices virtually. Okay, so how we can achieve this? As we have seen that some instructions may require some sort of privileges. In otherwise, if you don't maintain separately privileged and non-privileged, system may crash. Why? Because some programs may manipulate the or will damage the hardware resources by their execution. And so it's like suppose a storage is there. If you create direct access without any monitoring, then what it can do is, it can delete entire data which is exist, okay, which belongs to other users. That also possible. So such kind of instructions manipulating or modifying the memory or the storage will be controlled by virtualization layer. So such kind of monitoring controllability we should have. That's why this privileged, non-privileged, all these things come into existence. Yeah, this here if you see in this diagram, we are having virtual machine 0, 1, 2, 3, so on n. Okay, here we are having guest operating systems associated with this, some applications. Now what we are achieving here is virtualization of processor, memory, and I/O devices. This particular Intel offers this virtualized memory and I/O devices through the protocols called VTX technology or VTI technology for processor, EPT for memory, and DMA and VTD and VTC for I/O devices. See, for processor and memory, it is using VTX, VTI, EPT, whereas I/O devices, Intel has developed technologies like VTD and VTC in order to provide virtualization of processor, memory, and I/O devices. Okay, this is one example only how Intel has prepared, has achieved this virtualization. Next, coming to this CPU virtualization, as we have seen, unprivileged instructions of VMs runs directly on the host machine for higher efficiency. We have seen this, right? Other critical instructions should be handled carefully for correctness and stability. Okay, these critical instructions which requires some monitoring, can be divided into three categories: privileged instructions, control sensitive instructions, behavior sensitive instructions. These are the three types of critical instructions. And now coming to the definition of virtualizable, the CPU architecture is virtualizable if it supports the ability to run the virtual machines privileged and unprivileged in both the instructions in user mode, and VMM, whatever the hypervisor we are running, that should run in supervisor mode. So hypervisor will take care of all the instructions, whatever the sensitive instructions we have, those will be taken care by VMM. So that has to run in supervisor mode. Whereas for end user, it should give an illusion that it is running in user mode itself, so that that flexibility the user will feel or the guest will feel. That is the CPU virtualization. Through this CPU virtualization, what we are achieving is we are giving an illusion to the CPU, the user, that he could able to run both privileged and non-privileged instructions in user mode itself, while VMM will run in supervisor mode. Okay, this is CPU virtualization. And coming to this memory virtualization, here there is just 3-4 minutes I'll take. Memory virtualization, here nowadays we are having this primary memory, secondary memory, these kind of things. And in operating systems or in the CO, you might have come across memory mapping. Memory mapping, what does it mean? Or the concept of virtual memory. Yes, virtual memory. Have you come across this word? Yes or no? Please respond now. Virtual memory.
RAM, sir.
Yeah. So that virtual memory is nothing but although the primary memory is limited for programs which requires more memory, we will be giving an illusion that there is a large memory exists as primary memory. Got it? Although RAM is limited, we could able to run a program. Suppose let us consider RAM is of size 1 GB, and we wanted to run a program which is having some 2 GB length. Then how we could able to load that program into main memory and run? These are things not to be bothered by the user. Why? Because we will create a virtual memory. Okay, we will create some sort of illusion to the user that there exists primary memory of a large capacity. We could able to run even large programs as well. Such kind of illusion we will be creating. That is nothing but virtual memory. But so what user will do is user will create memory addresses accordingly. That is he will think that he is having large enough memory, so he will be giving the memory address in that way only. It's like suppose only two digits we have to give a roll number, then how many roll numbers we can give is maximum 99. Suppose if you say you can give you are having the space to go up to, what you call, up to 1000. Okay, up to 1000 you can give means I will be giving the number as a 999, 900, 901, like this. I will be giving 3 digit, but actually we are having the memory space for only 100. So there should be some mapping. Even though if I give 901, that has to be mapped to some of the addresses from 1 to 99, 01 to 99. So that mapping we call it as memory mapping. Okay, address translation we will be performing in virtual memory. This entire concept you might have come across in virtual memory actually. Here, while coming to the memory virtualization, on top of that virtual memory, we will be having one more layer. Just I will show you the diagram so that you can understand clearly. Here, this is the one. Virtual memory, VM1 here, virtual machine 1, virtual machine 2. Here, this is the physical memory actually. But in the virtual memory, virtual machine, what we'll be having again storage, right? This we can, this it will consider as actual memory. This it will consider as actual memory for this virtual machine. But these process will generate virtual addresses. These virtual addresses will be mapped to actual physical addresses, but these are also virtual only. Why? Because these are virtual machines, so these will be mapped to actual memory or the machine memory. Okay, two levels of mapping or the address translation we have to perform. Why? Because just you consider single virtual machine. This will be done in the case of normal computer. When we use virtual memory, it is like although we are having limited memory, here you see limited memory we are having. This process 1 requires this much memory and process 2 requires this much memory. Everything will be mapped to corresponding physical memory. This is in the case of normal machine. Whereas in memory virtualization, this itself is virtual memory. So what we will be having is another mapping from these virtual memories, these memory addresses to actual machine memory. Okay, this is a two-level memory mapping procedure. Now, if you read these two sentences, we'll wind up this class. In a traditional execution environment, try to understand these 2 points. Just the operating system maintains mappings of virtual memory to machine memory. In general, we'll be using page tables, which is a one-stage mapping from virtual memory to machine memory. However, in a virtual execution environment, virtual memory virtualization involves sharing the physical system memory in RAM and dynamically allocating it to physical memory of the virtual machines. We'll be creating virtualized environment where we are mapping, where we have to provide some memory to each virtual machine. Okay, that means a two-stage mapping process should be maintained by the guest operating system. Okay, here one is virtual memory to physical memory and another one is physical memory to machine memory, as we have seen here. Virtual memory to physical memory to machine memory. In general, in a normal system, we will be having up to this. That is, this will be the machine 1, this will be the virtual address. But here we are having two-stage memory mapping. Okay, this is about memory virtualization. In the next class, we will be seeing the other types of things. Okay, you please enter your roll number and can leave. And exam will